So let's talk about what this means about this course. What does it mean for it to be a proof-based course? You may have encountered proofs in some point during your mathematical career. Maybe you had something of an advanced calculus course, or maybe you had a intro to logic and sets type course. Here at A&M, the course is called Foundations of Mathematics because that's essentially what proofs are. They're asking us to go back to the very foundations of mathematics and redo what we know about even the most basic questions, like what is a real number? What is a real number? That's something that's kind of is difficult to answer. How would you go through and, you know, construct the real numbers from what we know from other types of things? Well, it all comes from axioms. Axioms here meaning just basic truths that are taken without proof. They are things that allow us to extend from those axioms into theorems, definitions, and proofs, things that we can start connecting to all the way out into the tools that we know of in calculus, the big theorems that we have learned throughout our course in an undergraduate career in mathematics or some adjacent field. So, in general, proofs just mean convincing arguments, and they help us see the connection between mathematics that we've learned and the mathematics that we are learning. And then at the end of the day, they all come back to the axioms of mathematics. That is where the rigor in proofs come from. That is what prevents us from just saying, "Oh, let's just talk in a circle." And most eventually, I'm sure that we'll be able to understand what the topic is. That's more for a kind of a intuitive understanding of a topic, which is very useful. But those intuitive understandings in general are not proofs. Proofs are things that are based on the definitions, theorems, and the ideas of proofs that we have from previous parts in a course or for somewhere else in mathematics. It all connects back somewhere. We'll see that the ideas, they just constantly are going to be building upon themselves in this course. And that's important for how we learn things in this course as well. Sometimes I will go through a class and I will take the first 5 weeks and I'll take an exam in it. And then after that exam is in, I don't know, tell you what I'm going to do with that course content I just been learning in that past few weeks. I'm going to forget it all because it's a new 5 weeks. I've got to have room for the new stuff that's coming in. I want to encourage us in this course not to be forgetting anything that we learn in this course. Instead of learning it to do it for the exam and then later forget it, I want to help us learn these things in order to archive it, put it in an archive spot in our brain so that when we come back to it later on, which we will, this course builds on itself very, very much. When we come back to it later on, I want us to be thinking, okay, I've got something like this archived in our brain. Let's see if we can pull that back out and start making connections to that again. The way that we're going to be, if you will, compressing information here is by making connections. And actually, proofs are going to be the ways that we make those connections. That will be helping us see the connections between everything in our brain and will help us compress things. So instead of learning a bunch of stuff to forget it, let's see if we can learn things deeply enough that we understand the inner machinations of what's going on, the connections behind everything. And the way that we're going to be doing that is through proofs. Now, here's the way that I usually will write proofs. Sometimes a proof will be written something like this. Maybe we have a beginning way of saying, okay, maybe there's a theorem that has us saying something like this. A sequence S of n is convergent implies S of n is Cauchy. So something like this. Maybe this is the theorem that we're trying to prove. Well, if we're trying to prove this, we have a place to start and we have a place to end. An implied statement gives us something to begin with, a sequence that is convergent, and then something to end with, a sequence that is Cauchy. So we can start from the definitions of what these things are. And you can see that I have those written in the beginning and the end parts here. Now we'll talk about what it means to be on the left and the right sides of these diagrams as we go throughout this course. This is a way that I like to work through proofs, is to have a clear starting point and a clear ending point. The thing that is not very clear is what goes on in the middle. And the middle is a way of connecting things from what we want and what we have. If we have convergent, we want to get to Cauchy, we need to find a way to connect the two definitions here. So it's good for us to make sure that we really know these definitions as we go through and start out. You may be a while to catch up on what these quantifiers and what these definitions and all that stuff mean. We haven't really talked about sequences yet in this course, but I'm just using this as a building example. So you might look at these definitions and start realizing, oh, okay, well, there's a lot of similarities in these definitions. Maybe I can find ways to leverage parts of one definition against one other part. For example, noticing that here I have the same beginning part in each of my definitions here. For all epsilon, there exists an n such that, and so on and so forth. So that's the sort of stuff that we have kind of to work with in building proofs, is that we have building blocks. We can work some from the beginning, we can work some from the end, and then eventually we can find a way to connect the two. And that connect the two, this is going to be kind of like the main idea of the proof. So sometimes you'll see us go through and do something in this class which says proof idea. It's not going to be an actual proof because we're not actually distilling the definitions down to their core elements. Instead, we're just giving a main idea of what goes inside of this little box. How do we connect the things on the left-hand side where we start from and the things where we end? Right. So once you see proofs a little bit more, we're going to be a bit more familiar with how this whole structure works, but you're going to see this diagram a little bit through this course because this is my way of trying to build through proofs, knowing where to start, where to end, and starting to build from either side to get to the proof idea somewhere in the middle. That gets us to the last slide here for this video. And for this, I just want us to think about what it means to succeed in this course. One way that I think it means to succeed is to celebrate the things that you've learned. This is a big theme for me. If we have done something, it's good to celebrate it by remembering and recalling the things that we have gone through, the cool things that we have seen and gotten to experience together by watching these shared experiences. So my recommendation is after each lesson, go through and try and solve a problem now, a problem you couldn't have solved before having been exposed to this content. This will help us not only celebrate the things that we've learned, but also cement the progress that we've made. This makes it so that your brain has like a point that it can cement everything to. It says, okay, this is a problem that I could have done now, but I couldn't have done before. It starts making those definitions and stuff make sense. So that's my recommendation, is to start maybe even going through the homework or going through and seeing something else in mathematics to start seeing, okay, I can start solving these problems. This means that I want this homework to be a day-by-day process for you, not just to cram everything in on the very last day type of experience. Because what that does is it says, I'm going to learn all this material and I'm going to forget it the next day. Remember, that's not the way that we want to progress through this class. We want to be archiving this material, and that's something that is better done through a day-by-day process. So after you take a lesson, a video lesson, go find a problem and try and solve it through. You can also use the Canvas calendar for this course. It has a to-do list. You will see that all of the to-do things, the due dates, everything in there is automatically in your Canvas calendar, and you can access that through your Canvas course. So if you see a little to-do list pop up, you can use that to make your own to-do list for what needs to be done at every point in the week, what videos are going to be done, when homeworks are going to be due, and what other things are kind of coming up for us in the course. Make sure that you are starting your homeworks early, not only to cement your learning, but also so that you can participate in online discussions with your peers. That's where the forum boards that are going to be posted on Canvas are going to be posted. This way you can get assistance from your other peers as well as assist your other peers. Sometimes when I'm learning at first, I like to get help from other people because I need different perspectives. So I need help from all of these other peers. So I like to ask a lot of questions to make sure that I'm understanding where things are coming from. But after I've learned something, I find that the best way for me to really get that learning down is to try and teach it to somebody else. It makes it so that the words have to come out of my mouth. My own words have to be used to get the concept going. If I just have it in my head, then maybe it's like, oh, maybe it's there, maybe it's not, right? I can have a fragmentation of the idea, but maybe not the idea itself. Having the words come out of my mouth says, okay, I now can see what I am understanding, what I'm not understanding. So teaching a concept can be a huge deal in order to be successful in this course. Another neat reason, another neat thing about the homework, by the way, is that the homework is going to help you study for the exams. You'll see that the homeworks end up being, because they are a lot of the course content for this course, the homeworks will end up being pretty lengthy. There's a lot to go through in each and every week, and we want to make sure that we're really hammering these concepts home. So you'll see that we do a lot of this homework here. But this is going to help you study for your exams, and while also giving you credit for the course. So this is a good kind of like 1-2 punch that homeworks can help us work through, getting us to study for the exams, as well as being ways that we can make sure that we are getting the points that we need to show our effort in this course is not for nothing. And then finally, this is my big thing again, just want to return to this. Always find time to celebrate math. There's a lot going on in our world. There's plenty of things happening in our day-to-day lives. But if there is a reason that you took this course, the reason that you're taking this master's program, I want that main reason to be that you want to see math jump out at you and say, look at me. I can do so much more than you ever thought. This is my experience with math as a professor. Even to this day, I look at math and I get all excited because I think this is a new thing I did not know before. So I want us to, as we experience new things we have not seen, I want us to find time to celebrate that, to enjoy that. I want us to have time to share that with one another, either in the forum boards or just with one another. So as you go through, I hope you find ways to celebrate math, however you celebrate. Maybe you're a type of person who likes to create. Maybe you're somebody who likes to journal. Maybe you're somebody who just wants to be in conversation with other people, either in your own personal life or here in this class. However you celebrate, please make sure that you do it. It helps it be so that in lieu of being around in a ceremonial type lecture setting, you are still getting the joy of going and learning. Right? The joy of learning is excellent. It's something that can be difficult at times, but the celebration makes it worth it. So if we don't have that celebration, it can feel like a toil. It can feel like it's just a lot of work for no real output for our own day-to-day lives. What it can do, though, what learning can do is make us feel like we've done something, that we have something to be proud of. All right. So let's keep going through the semester knowing that we want to celebrate math as we go through our day-to-day. At this point, I want you to go ahead and take a look around your Canvas course, see if there's anything that you have there. Send me an email if you would like introducing yourself. I'm happy to get to learn more about you so that I can know better about how to help you through this course. But for now, that does give us a good orientation, the place to start. You'll see me plenty of times throughout the semester. So this will be our format for kind of doing video-based learning. Thank you so much. Have a wonderful day.